All right. So we had seen a long time ago the concept of instantaneous center of rotation when we had planar movements or motions. Now that we are moving in 3D, that instantaneous center, which was a single point, may not exist anymore. But there is a generalized version of that notion. It's called instantaneous axis of rotation that we want to discuss now. So just to remind you, I don't know, that line, I tried to get rid of it, doesn't work. Just to remind you, we had this Euler's theorem, which was saying if there is I can't write, but there is a fixed point on a body, any displacement is equivalent to a rotation about, this is about a rotation about an axis that passes through that point. Here, displacement of the body, obviously, we're talking about. So that is Euler's theorem, but that is only valid when there is a fixed point on the body. In general, a general displacement, a general displacement can be thought of displacement of some base point on the body that moves to another point and a rotation about that new kind of considered fixed point. So in a general displacement, is equivalent to translation of a base point plus or superimposed a rotation about an axis that passes through that. This is that point. So I don't know if I have a body that rotates, becomes like that. These are the similar bodies but rotated. Go. Like that. You can think of a base point that translates to another point. So your system would look like, your body would look like this before rotation, and then a rotation about some axis that passes through that point. So you can always do this. There are a couple of notes here. Note 1, order does not matter, does not matter, and by that, either you do translation first, then rotation, or rotation first, then translation. They are equivalent. And note number 2 is that the choice of base point is arbitrary. So you can consider any point either on the body or on an extension part of the body somewhere else that we assume moves with the body. It could be any point. It defines how the translation part, I'm sorry, the rotation part that goes with it, how that one is, how does that one look like? But when it comes to base point, it is completely arbitrary. And that's interesting because you can choose any point, and it is possible to find a point that when you translate it and then rotate the thing, your body around that, the translation and axis of rotation are parallel. So it is possible to do that. And it is actually a theorem. So we had Euler's theorem. Now this is, I don't know exactly how to pronounce it. I think Chazels or Chazels, I don't know. Chas, Chazels. Oops. Theorem. And it states exactly that any general displacement of the body, let me write it. The most general displacement of a rigid body. Rigid body is equivalent to a rotation about a fixed axis and a translation or displacement. Translation, what kind of translation is that? Translation, it is translation. Let me write it better. Translation along a direction parallel to the axis of rotation. So that is a theorem. So it says if you have a body moving completely randomly, arbitrarily in a space, you can always find an axis that the body appears to be rotating about that axis and at the same time translating parallel to that axis. And this axis is sometimes called the screw axis. And the best example of it is a screw. So when you have a screw and a nut, as the nut rotates, it rotates and translates along the axis of the bolt. And this is exactly what is happening. And in general, for any motion, you can always find a certain axis of rotation and a displacement along or translation along that axis. So that is Chazels' theorem. And what is interesting is, well, maybe not interesting. What you can do is consider this at an infinitesimal displacement. So you have a body that undergoes a small change in position and orientation. Again, this Chazels theorem applies, And at this instant, you can find some axis of rotation that the body is rotating some delta or d theta around, and a displacement dr that the body is translating parallel to that. So maybe I should write it. Consider infinitesimal displacement. This is equivalent to rotation d theta about some axis, or let me write it. You should really write it. Let me write it differently. How do I write it? There is, it's not equivalent anymore. There is an axis that body rotates some d theta about that and translates dr. Do I need vector dr along that axis? No, I don't need dr. Just the scalar. And this axis, when you rewrite the same sentence in the angular in the velocity and angular velocity term, so omega is about let me think. So let me write it this way. Now this is equivalent to superposition of omega and some v, both along the same axis. Both along the same axis. So v moves in this direction and your omega is in the same direction. So the vectors are, these two vectors are parallel, vectors of omega and v. And this axis at this instant that omega and v are parallel is called instantaneous. I always just stumble here. I think EOUS, instantaneous axis of rotation. Or sometimes they call it instantaneous screw axis. And again, the best example is a screw. So the axis of a screw at any time is the instantaneous axis of rotation, because as your nut rotates, it also moves along the axis of the bolt. And when you think of it as a two-dimensional case, when we had the planar motion, so in planar, motion, and something I should have mentioned it. This is only valid, of course, when omega is not zero. So you have some kind of rotation. If you don't have rotation, well, it doesn't make a lot of sense to have instantaneous axis of rotation. When you don't want to have rotation, everything is moves with the same direction. Do you call that axis of rotation? I don't know. I wouldn't. Anyways, in a planar motion, omega, if you have omega is always perpendicular to the plane of motion. And the velocity of your body is always in that plane. So you don't have any velocity along the axis. So axis of rotation in this case is just the point that essentially the axis of rotation and the plane where they intersect, that becomes the instantaneous center of rotation. So instantaneous center is essentially a special point on that axis of rotation. And note that this V may exist or it could be zero. So in that case, this superposed velocity V in a planar motion is zero. Let me write it down. And this V out of plane motion is zero. So here, instantaneous axis of rotation is also perpendicular to the plane and coincides with what we call the axis center of rotation. Coincides with the plane and instantaneous center of rotation. I see. Okay, so that is really all we have for the topic of angular velocity, the kinematics, essentially the kinematics of the rotational kinematics of rigid bodies, I would say. And in the next module, we'll start looking at dynamics of rigid bodies. So it was a long chapter, but we made it. And yeah, let's see how it goes with the dynamics. Until then.